Hi, Bill Vales here. I recently had the distinct pleasure to cover the Littleton Middle School Science Fair. The Science Fair featured projects done by the 7th and 8th graders. I was able to interview several of the students as they were finishing up their projects a few weeks prior to the fair. I was also able to attend the Science Fair to shoot video of the many participants and visitors. It was a festive and exciting event. This event made me proud to see what students in Littleton are learning in science. The students showed a great understanding of their projects and science in general. Their enthusiasm for their projects was infectious. A special thanks to teachers Valerie Finnerty and Beth Stevenson for helping me to organize the filming. I hope you enjoy watching the Science Fair as much as I enjoyed filming it. Thank you very much for watching. Hi, I'm here at the Littleton Middle School, and we're previewing some of the Science Fair projects, and I'm here today with Alicia Patel. Alicia, how are you?
Good, thank you.
Okay, I see you have a project here on your, what do you call these boards?
Our Science Fair board.
Okay, that makes sense. Science Fair board for a Science Fair. So what's your hypothesis of your project?
My hypothesis is nanotechnology will clean up more oil because the dispersants need bacteria to break down the oil.
Okay, so nanotechnology. So you're going to have to help us through that a little. What is nanotechnology?
Nanotechnology or nanoscience is the study of anything really small.
How small is really small?
Microscopic organs.
Microscopic in nature, okay. That would seem to have some challenges involved with how you engineer things.
The nanotechnology I used was ferrofluid, so that was easier to see because it is nanotechnology mixed with a surfactant, so I could see it with my naked eye.
I see. And you said ferrofluid?
Ferrofluid.
And is that, what is ferrofluid?
Ferrofluid is nanotechnology, which is iron fillings mixed with a surfactant to create a magnetic solution.
Okay, I thought ferro was iron, Fe on the periodic table, right? Okay. Okay, so you have your hypothesis here, and cleaning up oil spills, that's really a great thing for the environment. And what inspired you to do this?
The 2010 BP spill in the Gulf of Mexico.
That was really an event, wasn't it?
Yeah, it was.
Yeah. How did you feel when that happened?
I was upset mostly because of all the animals that were being harmed, and that was where my main inspiration came from.
Excellent. Okay, Alicia, can you tell us now some of the experiments you did to test your hypothesis and what some of the results were?
To test my hypothesis, I filled a petri dish with 17 milliliters of water and added 5 drops of oil to each dish.
And this was the ferro oil?
Just plain, like, oil that you'd find, like, at a gas station.
Okay, so this was the oil that you were going to clean up?
Yeah.
Okay.
And then to do the cleaning up, I added 5 drops of ferrofluid to one dish and 5 drops of dispersants, which is my other method I was testing, to each dish. And I waited 5 minutes to let the method soak into the oil, and then I used a magnet to pick up the ferrofluid.
A magnet, very interesting. What role does the dispersant play?
The dispersant is a object that breaks down the oil. It has ethanol in it, which breaks down oil.
Okay. And you use a magnet to then pick up the oil which has been attracted to the
Ferrofluid.
ferrofluid?
So the ferrofluid magnetizes the oil, so the oil and the ferrofluid gets picked up together by the magnet.
I see. Did you think of this idea?
I was looking on the internet. I saw that MIT started this,
Yeah.
but they didn't finish the project, so I thought it'd be a cool idea to finish it. So
I think this is a great idea. So what were your results?
I found out that the ferrofluid is 15% more effective than the dispersant, and that the ferrofluid works better
Wow.
overall.
Wow. Did you have to use any particular type of magnets?
I used a neodymium magnet, but I don't think it matters what kind of magnet.
A neodymium magnet? Okay, so that's a rare earth
Yeah.
element. Okay, so those are pretty strong magnets.
I thought that the stronger the magnet, the more oil it'd pick up. So I chose that kind of magnet, but you could pretty much use any kind of magnet.
I see. Where did you get your neodymium magnets from?
I found mine on Amazon, but I mean, you could find one at a specialized magnet store.
Okay, okay. Ideas like this hold a lot of promise, I think, for our future. And, you know, my hat's off to you for coming up with this idea, or at least bringing it further forward and doing some experiments to show the validity of it. Are you pleased with the outcome of this?
I am very, very pleased at the outcome.
Yeah, okay. Well, you should be. Well, thank you very much for your time.
Thank you.
Thank you. I'm here still at the Littleton Middle School looking at some science fair projects, and I'm here with CJ Weber, who has a trashy project. CJ, how are you?
I'm good, thank you.
Good. This looks very interesting. Can you tell us a little bit about your project here?
So what I did was I was trying to find which trash bag could hold the most weight by putting weights on them and then seeing how much weight it could take before it broke.
Okay, so how would you characterize then what your hypothesis is?
So I found out which trash bag was the thickest and what kind of texture it had, which led me to my hypothesis that the Glad Force Flex would hold the most weight because it was one of the thickest and it had a kind of diamond texture, so I thought it would hold the most weight.
How many different trash bags did you use?
I tested 4 trash bags, and each kind of trash bag I tested 4 times.
Okay, 4 trash bags tested 4 times each. Did you find that the trash bags were made out of the different materials or the same materials?
They were mostly made out of just the same materials. So.
Okay. Okay, CJ, can you tell us a little bit about what sort of experiments you did and how you went about proving your hypothesis?
All right, so the first thing I did was I cut out a section of the trash bag, and I used several straps. This is the first kind of strap I used. It's a Velcro strap, and then I'd strap it onto this trash can, and then I'd put the weights on top and see how long or how many weights I could add until it broke.
I see. So the trash bag was over the top here?
Yeah, and
Okay.
then it was strapped using this, like just around.
I see.
Yeah.
I see. So the trash bag was fairly taut.
Yeah.
Okay. And what sort of objects did you put on there?
We used dumbbell weights, like the kind that you'd lift at the gym.
Okay. That you should lift at the gym. Okay. And what sort of weights, in terms of, you know, the amount of weight were you dealing with?
We used all kinds. We used everywhere from 1s to 20s. We used 5s, 8s, and then we used roll of quarters for half a pound.
Okay.
So.
Okay. And what were the results in terms of the amount of weight that was held and who the winner was?
So all the trash bags pretty much held the same weight except for one, which was the Glad Force Flex, which held a lot more than all the others, which held, I believe, it held an average of 49 kilograms. So.
I see, 49 kilograms. Okay. So, CJ, what inspired you to select this as a project?
So I wanted a experiment where the results could actually be beneficial and someone could actually gain some knowledge from my research.
I can see how this would certainly help consumers know the quality of the products that are being done and whether some products even work.
Yeah.
Yeah. You have a lot of data here, and how many bags would you say you went through?
We actually only went through 4 bags because we cut each kind of trash bag into 4 sections so it would fit on here. So we actually only went through 4.
Very good. Well, I want to thank you very much for sharing this with us. This has a lot of practical application, and your board here is very colorful, and it has such a witty title. Thank you very much.
Thank you.
Hi, I'm here with Matthew Krampf, and Matthew has a very interesting project. Matthew, tell us a little bit about what you're doing here.
Well, the project I am doing is a sweet and sticky earthquake shake.
A sweet and sticky earthquake shake. Okay, that's interesting.
Yeah, I chose this project but because I like studying earthquakes and looking at sites called the USGS, which is the United States Geological Survey, and they research earthquakes and do current volcano alerts.
Okay. And do you monitor the status of earthquakes in Littleton and the United States and the world?
Yeah, I monitor earthquakes all over the world.
On a daily basis?
3 times a day, maybe.
So you're into this?
Yeah.
Okay, great. Okay, what was your hypothesis?
My hypothesis was that the bedrock out of the 3 different soils will amplify the side-to-side earthquake shaking the most because the bedrock will not liquefy in an earthquake because it's hard.
Okay. You're testing my knowledge of P waves and S waves and those sorts of things. Okay, so that was your hypothesis. Where does the sweet and sticky come into this?
Well, I was building test houses for all of these different soils that I was using, and the test houses were made out of sugar cubes, which are sweet, and peanut butter or soy nut butter, which is sticky.
Okay. Did you gain any weight doing this project?
No.
Okay,
not
well,
really.
yeah. Okay, so tell us how you went about doing some experiments.
Well, each experiment I had 3 different types of soils: gravel, which was grape nut cereal; Play-Doh, which was bedrock; and sand, which was cornstarch in water, and that acted like liquefaction, which is basically the ground turns from a solid to a liquid.
Right, and we see that occur when we get mudslides and things like that.
Yeah, and they usually happen during earthquakes. So.
Yes, yeah, and why would that usually happen during an earthquake?
Well, it's shaking the ground and it's making the ground very unstable, and it just liquefies.
Yeah, very good, very good. Okay, so take us through some of the experiments you did and how you did the shaking and those sorts of things.
I built 9 test houses. Each house was tested on the soil 3 times, and I shook them in a game box that's filled with marbles, so the tray would balance on the marbles, and I shook it for 20 seconds, and at the end I would record how many walls fell or broke.
Okay. How many, and how many shakes per house would you have done?
Well, there were 9 houses, 3 of them for each soil, so I shook one. I shook each one time.
Okay. And what were your results?
Well, my results did not support my hypothesis. I thought the bedrock would support it because it's hard, but instead the sand, which acted like liquefaction, kept the house in the ground, and so when I shook it, it didn't move at all, and nothing fell or nothing broke.
Okay. Were you surprised by that?
Yeah, I think when liquefaction does happen during earthquakes, the ground's usually unstable and the houses just fall with it, but this time it didn't.
So if you know that that's how you've observed it to work in nature, why do you think that there might have been a difference in your experiments?
Well, definitely these houses are not real size houses,
Sure.
and yeah.
So the materials of
Yeah.
the house and
And liquefaction here, it's not cornstarch and water in real world. So.
exactly. That makes a lot of sense. What's the biggest earthquake that you know of?
It happened in Chile in 1960. It was on May 22nd, and it was magnitude 9.5, and it took the Earth. It made the Earth's axis a millimeter off.
Actually, knocked the Earth. That's
Yeah.
interesting. Now, we seem to have earthquakes in Chile, San Francisco, Alaska. What is it about that part of the world that we get earthquakes?
Well, it's along the Ring of Fire, and the Ring of Fire has it's violent earthquake zones because of tectonic plates, and also lots of volcanoes around that area. Actually, I started liking earthquakes since I experienced an earthquake in San Francisco in 2014. It was magnitude 6, and we felt it during the night because it happened at around 3 in the morning, but it was very destructive, but there was very little injuries, so it was good.
Where were you when it happened? Were you inside or outside?
I was inside a hotel at the time, and I think the earthquake was maybe 15 miles from where I was. So.
Okay, when you say where it was, you're referring to the epicenter?
The epicenter of the earthquake, yeah.
Okay, so you were pretty close to that. And you didn't like earthquakes before then?
I just didn't really know what they were before then.
Okay.
And then last year in 6th grade, in the classroom below us, my teacher taught me about earthquakes, and I just really ended up liking them. So.
Okay.
Yeah.
Okay. This is really interesting. I love geology, so I'm thrilled to see that there's interest in geology and they're supporting that in the school. This is a very interesting project that you did, and I understand the hypothesis. And
Did you know fact?
did I know what?
Did you know that the swimming pool at the University of Arizona in Tucson lost water from sloshing caused by the 1985 magnitude 8.1 Michoacan, Mexico earthquake 1,240 miles away?
Okay, so when you say sloshing, because the sloshing caused the water to leave the
Yeah.
container,
Yeah.
so to speak?
It actually left the pool. So,
Okay,
yeah.
okay. So on a smaller scale, what is that actually demonstrating?
Well, that earthquakes can be felt over a really wide area, and they can just like, yeah, I think that's it.
Okay, but that sloshing is
Yeah.
similar to a tsunami.
Yeah.
You know, what would happen in a large area when...
Yeah, just the pool was very small, so
Yeah,
it
yeah.
didn't hurt anybody, nothing like
Yeah,
that. So
yeah. Boy, that's interesting. And 1,240 miles away. Great. Well, not great, but so this is a great project. Again, I love the hypothesis and what you're studying. I see there the Haiti earthquake.
Japan earthquakes down there, Nepal,
Yep.
and the Pakistan earthquake also.
Yep. Do you aspire to study earthquakes, geology,
Well,
and those
yeah,
sorts of
when I
things?
grow up, I want to work for the United States Geological Survey and go around the world and track earthquakes and warn people of upcoming disasters.
Great, very good. Well, as you can see, they study a lot of interesting things at Littleton Middle School. With every project I've looked at and people that I've spoke to, I've really been impressed. So, Matthew, thank you very much. And are you going to be at the science fair?
Yes, I will be at the science fair.
We'll be looking you up. Thank you.
Thank you.
Hi, I'm here with Amr, and Amr's a Littleton Middle School student, and he's going to talk to us about his science project. Hi, Amr.
Hi.
So, what do you have for your science project?
I have a solar panel, and I did solar because I thought it would be fun, and I always loved energy.
You like different types of energy?
Yes,
Yeah. Have you done any other types of energy?
yes, I've done wind.
Okay. Okay. And now you're on solar.
Yes.
Okay. What is your what's the idea or a hypothesis that you're trying to show with your experiment?
If the angle of a solar panel is changed, then the most amount of power will be produced when a light shines directly onto the solar panel.
Okay, so you have some experiments that are going to demonstrate this?
Yes.
Okay. How do you set up your experiment?
So basically, this is a clamp lamp, and so I put it at 30 centimeters high, so it would be able to shine directly on it at the different angles.
Okay, why don't we take a measurement of that as an action shot?
Okay.
Great. And that's 30 centimeters.
Yes.
30 centimeters.
Yep.
Okay, we don't use inches in science, do we?
No.
No. Okay, metric.
Yeah.
Okay. Okay, now, what do you do?
So basically, I have this. This is clamps,
Okay.
and so here I have a multimeter.
A multimeter?
Yes.
And what's the multimeter used for?
Multimeter is used to find the amount of volts or watts the solar panel is giving off when the light's shining on it.
Okay, so that's going to be your device for measuring.
Yes.
Okay, okay. Okay, hook it up. Do I have to worry about shocks or anything?
No.
Okay. Now, what do we have here?
This is the solar panel.
And where did you get this?
Amazon.
Amazon. Now, I mean, you must have known for this idea that you needed a solar panel.
Yeah.
Okay. Had you ever seen these solar panels used before?
Not like this. No.
Okay.
I've seen like regular big ones in like for houses or for like cars and stuff.
Okay. Let's
So if I turn it on,
you always have to plug it in.
one, 1 second. If I turn it on,
Okay.
you can see that it's working.
Oh, flip it over. All right.
Yep, so, see, that's just,
Okay, let's put it like that.
it's flat. So the light is shining directly on it.
Okay, now, what is this measuring?
16.6 watts of energy. Or
Watt?
volts of energy.
Okay.
Yeah, with a 100-watt light bulb.
Okay, so there's a 100-watt light bulb in here.
Yeah.
And of that 100 watts, this is probably getting 17 watts, thereabouts. Oh,
Yes.
So what's that say when my hand goes in the way?
When your hand's in the way, so it goes around your hand, and it's less, so it's 3.4. I'm going to say
Okay.
3.4
Okay.
watts of volts of energy.
Because I'm blocking the
Yes.
energy. Okay, let's do an experiment.
Okay, so now you see it's about 17.9,
Okay.
so
0.5.
0.5,
Yeah, you can't quite see the.
0.5.
Yep.
So if I put it at an angle like this,
Okay.
you'll see it has gone up.
Okay.
So that's because it's getting closer, and the light's shining more on it, so it should go up more.
Okay.
And then if you put it more up, see it's about the same
Mm-hmm.
because it's already been at like here,
Mm-hmm.
so it'd go here.
Yeah. Now,
Makes
I
sense.
also noticed that when you pulled it up, you moved it away from the light, you
Yes.
know, here, so there's less surface area.
Yeah.
Okay. So that must have something to do with it too.
Yes.
Okay. Okay. Let's tip it some more.
Yeah. So maybe I can use that.
Sure.
Maybe. See if it's more. Now it's saying 19.2
Yep.
watts of energy.
Okay.
So that means, I guess, the closer it is, the
Mhm.
more it is on the closer, the more watts it'll produce.
Okay. Now, this is actually modeling the sun, correct?
Yes.
Okay.
So since now it's winter time, the sun doesn't give off the most amount of energy because winter. But in the sun, like that's why like in the winter it's cold too because like it's not giving the most off
Okay.
of the energy.
But even if it's winter here, it's summer somewhere.
Yes.
Okay. All right. So how do you, so you take these different readings,
Yes.
okay, at different angles?
Mhm.
And how do you aggregate that data? How do you put that data together?
So basically, we have 5 different angles
Okay.
and 5 different tries.
Okay.
So you hold it. It stays there for 1 minute at each angle
Okay.
for 5 different tries.
Mhm.
So then at the 1 minute mark, you check it, and you record the data,
Mm-hmm.
and then this is the raw data,
I see.
and then here's the average. So
I see.
as you can see, as the solar panel got higher, the numbers got lower. The watts of energy got lower,
Mm-hmm.
which actually really surprised me. I thought it was gonna be a higher voltage because it'd be closer, but now it's giving off more. Yes.
Okay. Now I see you take this data
Yes.
and then you generate a graph out of it?
Yes. So this is the average. The graph is the average.
Okay.
So, as you can see from 0 degrees, it goes from like up and then goes down as it gets higher. And
I see. Okay. Well, what do you think this tells us about if you were going to put solar on your house or something like that, what would that tell us?
It tell us if it's more of an angle, that the sun it's not going to produce so much as if it's like this, but like this, it's not. It's going to hit off it, and some of it's going to come off.
I see. This is, it's great to see you working on projects like this, because with the demands that we have on energy use in this country and the world, it's really important that we bring technologies like this to the forefront. So, I congratulate you for coming up with this idea, to measure the power consumption, and I wish you a lot of luck taking this idea forward at the science fair.
Thank you.
Hi, I'm here with Riley, and behind us I want to make mention that we have several poster boards of various projects that are being worked on by Littleton Middle School students. But this particular board in back of us on growing crystals is not on the topic that Riley has done work and research on. Hi, Riley. What is your topic?
Well, I did a study of the effect of gender on the ability to hear audio cues, or, just does gender affect how a person can identify emotion through audio cues, which is kind of the simpler version.
Okay, and by an audio cue, what are you referring to there?
Like tone of voice.
Okay.
Like when someone's angry, can people tell if they're angry without seeing their face just by hearing it?
Okay. What is your hypothesis?
My hypothesis was that females would be able to identify emotions better because females' brains are proven to work faster than males' brains.
All right. I guess I'm going to have to hear some more about that. So, how did you go about? So you have your working hypothesis there. How did you go about trying to prove that?
So I asked 6 boys and 6 girls from the age limit, which was 10 to 20, and I gave them 5 different audio clips, and I gave them a multiple choice question. They had to answer it for each audio one to see which one got it right.
Okay, so now what's an example of some of the audio clips that you provided?
Well, like I had one where you could kind of tell that they were scared, but you could also kind of tell if they weren't confused because it said scared on it, but it also kind of sounded like confused, and that was one of the questions that people got wrong. A couple, yeah.
Okay. What were some of the questions that you asked?
They'd be very simple. They'd be like, is the person who's talking, are they scared or are they confused? It would just be two different ones, and then you would circle one of them.
I see. And with your samples, so you had males and females as part of your samples. What did your data come up looking like?
Alrighty, so with my data, it was very, very close, but the females did actually do it better. And with the averages, it was really close, as females got 4.6 and males got 4.3 out of 5.
Okay. Yeah, I mean, out of 5, that may be more of a variant than
Yeah.
you think. So, why did you choose this this experiment?
Well, I've always been interested on how people, like, when they hear things, how they process it. And I figured this project was probably the easiest to do, like, processing with, hearing and stuff, because there's a lot more complicated things I could do, but I'm not sure I'd have time.
I see. I know when I was growing up, I was very in tune to my mother's voice. And one would have to wonder if that has something to do with supporting your research, too.
Yeah.
What were some of the references that you made use of to help you work through your data?
Well, when I made my, whole research paper, I looked up with this, I had a diagram of the ear to see how, things went through the ear and went into the brain, and that helped me, write the paper. But, when I did this project, I tried to get a group, a very diverse group, I should say. I did have people age range not from till 20, but that was just because it was there. I had ages 10 to 16.
I see. Now, that's interesting that you actually looked at the biology of the ear. So did you find anything about the differences between the biology of the ear for a male versus a female that supported your results?
Not really, but I didn't look too deep into that.
But about doing research like that, it makes a lot of sense to be thorough and to look at different angles. That's great. Do you have a general interest in this sort of work?
I've always just been interested in humans and emotions and all those kinds of things. It's always something I've liked doing. I'm a pretty sociable person.
Yeah, I can tell. Well, I think this is a great selection of a project that you've done. I'll look further for this when we're at the science fair, and I wish you luck with your future studies and other experiments that you do.
Thank you.
Thank you. Hi, I'm here with Morgan, who has a very interesting project. Hi, Morgan.
Hello.
Can you explain to us what your project is about?
My project is trying to engineer a bioplastic that will dissolve in ocean water.
Okay, a bioplastic. What is a bioplastic?
It's a plastic made out of natural ingredients that will break down in the environment over time.
Okay. What sort of natural ingredients might a bioplastic?
For this project, I use different types of milks, vinegar, and like flowers, things like that.
Okay, okay. So, describe what you have here. You got some
So these weren't made by me, but they're examples of bioplastic. This is a milk plastic.
milk plastic.
Yeah. And then this one is a starch plastic. So,
Now, when you say milk, do you mean like moo?
yeah.
Really? So, what would something like this be used for?
I know they're not really used much today, but in the past, I believe they were used for making buttons and stuff.
Okay. And this is what again?
It's a starch plastic, so it was made out of like cornstarch.
Okay. Okay, and this looks to have the consistency like you could, well, what would you use this for? I guess this is a little more rigid than I expected.
Yeah, I don't actually know the history of that one. And I do think that it's like more recent than the milk one. Like it doesn't have a history as much.
Okay, so how do you put together, how would you state your hypothesis?
I actually don't have a hypothesis because my project was an engineering project. But I do have like an engineering goal, which was to make a plastic that would dissolve in the ocean water.
Okay, make a plastic to dissolve in ocean water. So I can see where that might be really good if plastic wound up being litter and found its way to the ocean.
Yeah, there's a lot of plastic in the oceans, and the main reason I wanted to do this was it's getting eaten by marine life, and it's like filling up their intestines and killing them. And then sometimes the marine life that's like died because of the plastic will be eaten by more marine life, and then it just keeps going because it doesn't break down at all.
Yes, that endless cycle. I know bird life is another problem, getting their beaks and heads caught in those various rings that used for tonic cans and things like that. Okay, so that's a clearly stated good reason to investigate this. So how do you go about testing your ideas and collecting your data?
Okay, so to test and like collect data, I made 3 different prototypes, each one with like a different like version of the plastic.
Okay.
The first time I had 3 different plastics, the milk plastic, the starch plastic, and then another one that I called microwave plastic. It was basically the same as the starch, only made in like a slightly different way, like heated up differently. And so I actually didn't think any of them would dissolve at all or break down, but the milk one ended up breaking down like a lot. It was within 2 weeks, which was more time than I wanted it to take. But since it was the only one that actually broke down, I decided to go in that direction. And so for the next prototype, I just like put different amounts of milk and like vinegar in, which were the 2 ingredients to make the plastic. And then to test whether or not they would actually like break down, I put them in a container, like a plastic Tupperware container with ocean water I had actually gotten from the ocean. And then I just let it like sit there for a few days, and I would only take it out to test it. And then I saw if it would break down over time.
When you took the material out, how did you go about testing it?
So for the first prototype, I actually didn't have a scale, which is what I used for the other 2 to weigh them, which is what I think of as a more exact means of seeing how they broke down. But I did measure the width of them and how that changed over time with a ruler.
Okay.
And I also traced them on graph paper to see how the shape changed.
Very interesting. So weight would tell us about the mass, right? Okay. So you would measure the thickness of that with a ruler?
Yeah, as I said, these aren't my plastics.
Yep.
Mine are more like in squares and like
I see.
flat, so they were easier than that one to measure.
I see. Okay, so how did you then collect your data and organize it?
I had I wrote down the weights of them over time and like how it changed. And
I'm always impressed with notebooks. I think that's great.
yeah, and then for my tables, this is the second one. Yeah, this is the. So this is for prototype 2. The dotted line is the average of the weights over time, and then the rest of them are for individual bioplastics. And then for each recipe, I had 3 different like little squares of it to make sure that the data, if there was like one that was kind of off, it wouldn't affect the data too much.
I see. So each of these lines here represents one piece of plastic.
Yes.
I see. And then as we walk along here on this axis, this is over time?
Yeah.
I see. And this represents, what does this represent here?
This is how much it weighed.
I see.
So they actually all gained weight at
Yeah,
some
yeah,
point
yeah.
because I think it's because they absorbed the water,
That would
so
make
they like
sense.
expanded and then they lost it again.
I see. Interesting. That's really interesting. So this chart clearly shows those results I mean, that's really put together in a clear manner. So what were your next steps then?
My next steps were really just making like the next prototype until I ran out of time and it was time for science fair.
Yeah.
So like I said, I ended up making 3 and I finished like measuring the last one like a week ago, I think.
So when you say you make your prototypes, the prototypes are actually the biomass?
Yeah.
Okay, I see. And then all these prototypes, are you putting them through the same sort of tests?
Yeah, they all go through the same test, which is putting them in the water, and I put 1 cup of salt water in each time, like for them to sit in.
Where'd you get the idea for this? This is really neat.
So it was actually kind of partly my mom.
Mm-hmm.
So she was reading an article one day in the Times, which was about how animals were eating the plastics and stuff. And so she gave it to me to read. And I came up with this because I was like, well, why isn't someone making something to stop this?
This is this is a wonderful idea that really merits a lot of attention, because this is the type of thing, as I see it, that really can really make a difference, in the world. Now, one thing that I'd wondered about was, does the breakdown of this have any detrimental effect of the ocean?
So I haven't tested that yet, like with a kit.
Yep.
But I think based on what it's made out of, no, like it won't hurt any of the animals because it's made out of natural things.
It's all natural. Yep. And that makes a lot of sense. So I think, but of course, with everything in science, we have to test that. So this is a great idea. I hope you continue to carry on this research. I think it's marvelous. So here we are at Littleton Middle School, and I want to thank you very much.
Thank you.
Hi, I'm here with Beth Stevenson and one of the teachers here at Littleton Middle School. And Beth, thanks for agreeing to speak with us.
No problem, my pleasure.
Yeah, I've been absolutely blown away by the quality of projects and the general acumen of the kids that I've spoke to. You have to be responsible for some of that.
Well, thank you, thank you. We've been doing science fair here at Littleton. Oh, I guess this is our 11th or 12th year of doing that, and the children actually start in November. The homework over Thanksgiving vacation is to talk about science fair over the Thanksgiving dinner table, because there's always an aunt or an uncle or a cousin who's done science fairs, just to get them thinking about it. And then we spend the month of December researching the topic and coming up with some background material to make a hypothesis. And then the rest of the work is basically done at home. I check in with them on Monday. So you're seeing the final project here.
Okay. Now, so this is pretty much a full year project that you're going through.
Well, so what, November, December, January, February, March? Yeah.
Yeah.
5 months. So it does take a while, but it's, as I said, it's once a week that I try to touch base with them, but it's, this is the scientific method, and so we do it with other topics that we study in class, but here they take something of interest, and I really encourage that. So that's why there's such a variety. The students can pick any topic they want to do, because spending 5 months on it, you don't want to have something assigned to you that you don't like. So as you saw with Matthew, he's just he wanted to do volcanoes, and a lot of people think science fair volcanoes, but that's a demonstration. So that's 3rd grade science fair, that's not 7th grade. So he was able to, working, doing some research, talking with me, talking, with other people, came up with he could still do his earthquakes, but on a 7th grade level.
With their area of interest, do they run that by you so you can vet it?
Yes, they have to do that, and to make sure that it's viable. And then also we go to the competition. Matter of fact, on the 9th, we have a regional competition at UMass Lowell, and then anyone that gets a ribbon there goes to the state competition in Worcester. So we have every student, we only get to pick 10 projects, 5 in 7th grade and 5 in 8th grade, but we have every student fill out a, I can't remember the name of the form, but it's how they're going to do it, and that's a safety check. So, I kind of do my own safety check, but just so that, basically, cover yourself there. So, so that is sent out too. So if there's any problems or concerns about that. So like 7th graders or middle schools can't use animals with backbones. So they can, I've had kids do earthworms and hissing cockroaches and planaria, flatworms, and those type of animals, but they can't do anything like with a frog or a bird or a duck.
Yeah. And why is that?
I think it's maturity level.
Okay.
Because oftentimes I'll have kids come up to me and they want to try different environments for worms. So basically they're trying to find out that, that you're going to kill them all. And so I try to work with them that I see they're interested in worms and they're interested in a certain aspect of it. And so I try to work with them. And of course there will be, some deaths with worms,
yes.
But it's a little easier to handle than if you're dealing with mice. So I think it's just a maturity level.
I see.
And again, that's a state rule. That's a state rule. We have had maybe over the 10 years 2 projects. One girl she was in 8th grade, but she was a 4-H, and she had chickens, and she wanted to do something with chickens, and so, Miss Affinity allowed that, but she also let the child and the parents know that no matter how great her project was, we could not send that to competition, because it's just not allowed at the middle school competition level.
I see. Do you make sure that the scientific method is followed as the students progress through their projects?
Oh yeah, that's what that every Wednesday check-in is. And so there's a little piece and then a little piece and a little piece. So, I don't like okay the subject in December and say, see you in March.
Yeah.
So every week it does that, and so they can't, that's why it's really hard for them to like to steal something off the internet, because there's a step, and they have to show the data, and usually the internet's not, you know, it's like a finished product, and I need to see the steps.
Yeah.
So we try to ensure that they do the work on their own.
Yeah, very valuable. I know one set of interviews I did with Valerie Finnerty's class. They seem to be following the scientific method, just as the students here today did. And I really have to say that I'm just really blown away by the quality of what I see going on here.
They work really hard, and we work really hard.
Yeah.
So,
Well,
so they're all done now. Now I have a stack of lab reports. So.
Yeah. Well, congratulations to the students at Littleton Middle School for what they've done. And are all the students required to participate in this?
Yep, they are, but they can work either by themselves. So I think you had all solos for the interview.
I did.
But they can work by themselves, in pairs, or in threes. And again, that's the state regulations.
I see. Well, I'm very impressed. I want to congratulate the students of Littleton Middle School. You know, from what I see, I want to congratulate the teachers, because a lot of this emanates from the teaching staff.
Well, thank you, but also the parents. The parents are very supportive in Littleton. You know, we do order like 100 boards, so they're only $3 as opposed to, $8 at Staples. And we do offer paper and help, but, again, all of the experiments are done at home. There are a few that, do it in the classroom, but so oftentimes the students will thank, their mother or their father for letting them, grow 27 plants in their dining room table. Or another student just told me how they had some candles that they were working with, and they thought they had protected the table, and they didn't. So I feel horrible about that. But all in the name of science, I guess.
Well, that will make a great story, though, when they gather around that table.
Well, I hope your mom thinks so, too.
In years to come. And that's very true, that the parents and having a supportive environment at home is really key to learning. So,
It is.
again,
Great community to work for.
congratulations on, what's going on here in Littleton. And I'm really looking forward to the science fair on Thursday, the
April 7th.
April 7th.
6 to 7:30.
6 to 7:30, so we're looking forward to that. So, thank you very much.
You're welcome.